Verify each of the following trig identities. On the first problem, sine x tangent x plus cosine x equals secant x. I'm going to take the more complicated side, which in this case is the left-hand side, and try to simplify it until it looks like secant x. I'll do that by first rewriting everything in terms of sines and cosines. So the sine x we can keep. Tangent x I can rewrite as sine x over cosine x. And cosine x we can keep. Simplifying this, our first fraction becomes sine squared x over cosine x. And the second term we can leave as cosine x. Since one of the terms is a fraction, I want to think of the other piece as a fraction also. We can rewrite this as cosine x over 1, and then get a common denominator by multiplying both numerator and denominator by cosine x. This gives us sine squared x over cosine x plus cosine squared x over cosine x. These now have the same denominator, so we can combine these together as sine squared x plus cosine squared x all over cosine x. By our first Pythagorean identity, sine squared x plus cosine squared x is 1. And then finally, by a reciprocal identity, 1 over cosine x is secant x. So this verifies the first identity. For the second identity, tangent x over secant x plus 1 equals cosecant x minus cotangent x. I see that we have a secant x plus 1. I'm thinking we might want to use the Pythagorean conjugate. So we'll multiply the numerator and denominator by secant x minus 1. So in the numerator, we have secant x minus 1 times tangent x. Our denominator, if we multiply this out, gives us secant squared x minus 1. Now by our Pythagorean identities, secant squared x minus 1 is the same as tangent squared x. So we can rewrite this as secant x minus 1 times tangent x over tangent squared x. Next, we can reduce this by canceling out one of the tangents. And then I see that the right-hand side has two separate terms, so I want to break this into two separate fractions. Secant x over tangent x minus 1 over tangent x. Now secant x over tangent x, to simplify this, maybe it would help to write this in terms of sines and cosines. So secant x is 1 over cosine x divided by tangent x, which is sine x over cosine x. For the second fraction, 1 over tangent x by our reciprocal identities is the same as cotangent x, which is good. That matches the second term that we're going for. On our first fraction, we can simplify this by multiplying both numerator and denominator by cosine x, which is our LCD in this case. That way the cosine x's will cancel, and we're left over with 1 over sine x. Our second term can just stay, cotangent x. And then finally, 1 over sine x by our reciprocal identities is cosecant x. This now matches the right-hand side, which verifies the second identity. On the third identity, I see that we're adding two fractions, so I'm thinking maybe get a common denominator. Our common denominator in this case will be cosecant x minus 1 times cosecant x plus 1. So we can multiply the first fraction by cosecant x plus 1 in both numerator and denominator. The second fraction we can multiply by cosecant x minus 1 on both numerator and denominator. We can now rewrite this as cosecant x plus 1 plus cosecant x minus 1, all divided by the common denominator, which is cosecant squared x minus 1. We can simplify this by combining like terms in the numerator. The cosecant x and the other cosecant x will combine to give us 2 cosecant x. The positive 1 and the negative 1 will cancel. And then in the denominator, cosecant squared x minus 1 we have a Pythagorean identity, which we can rewrite this as cotangent squared x. Now that we have this down to one term, we need to make this look like what we have over on the right-hand side. So maybe it would help to rewrite this in terms of sines and cosines. So we can write this as 2 times cosecant x is 1 over sine x, and cotangent is cosine x over sine x. But this was cotangent squared, which means this cosine is squared and the sine is squared. We can now simplify this by multiplying numerator and denominator by the common denominator, which in this problem is sine squared x. And then reducing these, I see that one of the sines will cancel in the numerator, and the sine squared will cancel in the denominator, leaving us with just 2 sine x over cosine squared x. Now keep an eye on what our goal is. We want to make this look like 2 secant x tangent x. We already have the 2. To make this more conducive to looking like the right-hand side, I'm going to rewrite this as 2 sine x times 1 over cosine x times cosine x. I'm just thinking of this cosine squared as cosine x times cosine x. And then finally, sine x over cosine x is tangent x, and 1 over cosine x is secant x. And this is equivalent to what's on the right-hand side, which verifies the third trig identity.